This is NV Fitton at Northern Virginia Community College. Today we are looking at rational functions. We're going to graph them and then we're going to ungraph them, working our way backwards from the graph to the equation. Now I think it's very important that you check everything that I say in these videos with both the calculator and with Desmos to make sure that you get the same result. And this also gives you the opportunity to make little changes in the equation that you put in the calculator or the grapher and see what effect they have. Okay then. So I have two examples here, numbers 11 and 19 in our text. Okay, number 11 is y equals 2 over 5x plus 2. Okay, now we have the extensive handout, this one, that tells you all this stuff that you can and should do with rational functions, but we don't always need all this detail. I want you to see that I can actually use transformations, the familiar stuff that we had the first week of class, to understand this graph. The first thing I'm going to do is to factor the denominator because it's a polynomial, and that's what I just can't help doing every time I see a polynomial. Okay, so now I see that there is a 0 of the denominator at x equals negative 2/5, and we already know that that produces a vertical asymptote. But watch this. I'm going to factor a 2 out of the numerator and a 5 out of the denominator, which gives me 2/5 times 1 over x plus 2/5. And now I see that this element on the left, I'm sorry, that's my other left, is something that I know how to graph using transformations. So I know that 1 over x looks like this. Well, this is 1 over x, moving it a bit to the left, so the vertical asymptote is no longer at x equals 0, but rather at x equals negative 2/5. Okay, so there I go. Otherwise, I have the same horizontal asymptote that 1 over x has. Okay, and what else do I know about this? Let me see. I can determine what the y-intercept is because every function has either no y-intercept at all or just 1, which I can find by plugging in x equals 0. So I have 2 over 5 times 0 plus 2, which makes 2 over 2, or 1. So this point here is 1, 0. So I have my horizontal asymptote, which is like the horizontal asymptote of 1 over x. I have my vertical asymptote at x equals negative 2/5. I have my 0, there's only 1. Rather, that's the y-intercept, not an x equals 0. X never is equal to 0. It can't be. There's no x there at all. Okay? So, I think that's all we can say about this one. We're done. Okay, let's move on to number 19. Okay. 19 is y is equal to 4 minus 2x over 3 times, sorry, said that wrong, 3x minus 1. Okay, now let's look at the handout. And the first thing it says to do is to determine the long-term behavior that's another word for horizontal asymptote if you have one, or an oblique asymptote if you have one of those, or maybe you have neither one, but most of ours have one or the other. And so we look to see what which of the four possibilities we have here. Well, since the degree of the numerator is the same as the degree of the denominator, that means that we have a horizontal asymptote at y equals whatever the ratio of the leading coefficients is. Okay. Well, the leading coefficients here are -2 and +3. So this means I have a horizontal asymptote at y equals -2 over +3. In other words, -2/3. Okay, great. So, back to the handout. It says the next thing to do is to find the zeros of both the numerator and denominator by factoring. Okay. This will relieve a lot of tension because I feel better already once I have my polynomials factored. Okay. I have an error there, don't I? That should be 1/3. Okay. Now, referring back to the handout, if x is a 0 of both the numerator and denominator, we would have an insidious whole, but that isn't the case. These two have different zeros. Okay. If x is a 0, this q here stands for, well, it doesn't stand for anything. It's just that throughout this document I refer to p of x over q of x. Okay, where were we? If x is a 0 of the denominator, x makes a vertical asymptote. Okay. So, that means we have a vertical asymptote at x equals 1/3. And now what about the 0 right here? X that's a 0 of the numerator only, that is where x touches, or, well, does x, or the graph touches the x-axis. So that means that we have a 0 of the graph, in other words, an x-intercept, at x equals 2. Okay, so let's take these facts and start roughing out a graph. Okay, I have a horizontal asymptote at y equals -2/3. I have a vertical asymptote at x equals 1/3. And I have a 0 at x equals 2. So here's my 0 at x equals 2. So that point is 2, 0. And while we're at it, back up here, we have the x-intercept. The y-intercept is when we let x be equal to 0. So we have 4 minus 2 times 0 over 3 times 0 minus 1. So 4 over -1, which makes -4. Well, I'm going to need a bigger graph. Something like that. Okay. So, I know that I have a horizontal asymptote and I have a point here. I know that at x equals 1/3, I have a 0 of multiplicity 1. So that means that I'm going to have a situation like this. Like this. It's going to go either up on the left and down on the right, or vice versa. So I'm looking right here. Okay? So the question is, which one is it going to do? Well, it's got to meet the horizontal asymptote here, and it has to have a go through. So I believe it's going to look like this. I have a vertical asymptote there and a horizontal asymptote there. I'm sure we have a bit more beautiful arch than that, but we've got to work with what we have. Okay, if I have a vertical asymptote here, then I need this vertical asymptote to go the other way through this 0 and take me out there. So this one also looks like 1/x with somewhat different proportions. Here's how it looks in Desmos. And so we can see the x-intercept at 2, 0, and the y-intercept at 0, -4. And I'm going to put in that horizontal asymptote at -2/3. There, that looks good, doesn't it? And the vertical asymptote was at y equals 1, x equals 1/3. There. Okay, it came out very decent, and all we had to use was our brains. And there's a thought for the day, huh? Okay, that's the end of this one. I didn't realize I could zoom out. So there is a somewhat better picture of it. Okay, that's the end.